Okay folks, welcome to the lesson, plotting quadratic curves. I'll assume you've seen a previous video which is how to compile a table of values for quadratics. If you haven't seen that, I'd probably advise that you watch that, and then once you have your table of values, this video shows you how to plot the points and draw the curve. So let's crack on and get the job done. So here we have a table of values. We want to plot the coordinates from that table. Here there are the coordinates. There are our axes. Now take your time when you're scaling the axes. It's really important that your axes to begin with are accurate and correct. What do I mean by that? Well, on our scale, the numbers on the x-axis, for example, need to be properly scaled. If that's 2 squares for 1 unit, then it's another 2 squares to the next unit and another 2 squares, and actually mark the numbers on the lines of the graph paper. Similarly, if the scale going up the x-axis the y-axis, beg your pardon, from 0 to 4, 2 squares equals 4 units. 2 squares, another 4 units. 2 squares, another 4 units. So scale your axes accurately. Now, how do we know how big to make the axes? Well, we look at our table of values. So our x values need to go from -4 to 4. I've actually added a little bit extra on there. And our y values, let's look at the y values. Well, our smallest y value is 0. And we need to go up to 30. So our y value doesn't require any negative values. It only needs to go upwards from 0, and it needs to at least get to 30. I'll just put a little bit extra on the top. So our scale now on the x-axis and the y-axis will cover the table of values. And then once we've done that, let's just plot the points. When x is -4, y is 6. When x is -3, y is 2. When x is -2, y is 0, etc. So carefully and accurately just plot your points. And as you're plotting them, your graph should start to look right. It should look like a nice smooth curve. And once we've got the points, we're ready now to join them up. Oh, hello, what have I done here? Well, for the turning point, because the curve is going to turn, it's often easier, I think, for those who are right-handed, to be turning their book upside down and continuing the curve like that. Okay? It's just easier for the right-handed person to draw their curve like that. And then just make sure the curve has a little turning point there between x values of -2 and -1. And then when we've done that, this is what our curve should look like. And then we label it with its equation. As ever, let's look at a second example. These are the coordinates that we're plotting. So here is our scale. Once again, our x values from -4 to 4, they're covered by the x-axis. And we look at the y values to see how high we need to go up the y-axis, and we need to get as far as 29. That's our highest y value. There are no negative y values in the table. So our y-axis going up 2 squares for 4 units, 2 squares for 4 units, 2 squares for 4 units, all the way past 29, so we're up to 32. And on the x-axis, 2 squares per unit from -4 all the way to 4. And we plot those points from our table. And remember what I said last time, as you're plotting them, the points should look right. Try and make your points nice and neat and tidy, by the way, not big blobs, just little crosses will do, okay, and make sure you're plotting them accurately. So this coordinate here is the coordinate 2, 13. Well, it's easy to find 2. For 13, well, 12 is there, that's 14, so it's halfway between 12 and 14. So plot it accurately. And when we've plotted our points, we can join them up. Once again, for the right-handed person, it gets a bit tricky here, so we turn our book upside down and then continue the job. We just need to make sure we get a nice turn on this curve, so just take this carefully. Nice smooth turn, looking something like that. And that's what our curve should look like, a nice smooth curve, points joined up, and then labelled with its equation. In this example, we've got a negative x squared in our equation, so let's see what difference that will make to the curve. As ever, from those tables of values, these are the coordinates we are plotting. -3, -12, -2, -5, and then the remainder of the coordinates. So plotting each point carefully, x is -4, y is -21. That's that coordinate. -3, -12, -2, -5, -1, 0, etc. Plotting the points really carefully. Just use a little cross, a sharp pencil, and make sure you're plotting those points exactly where they need to be. And when we've done that, we're ready now to join the points up. A nice smooth curve, and then for the right hand side, in the turning point, turn your book upside down if necessary, if it makes it easier. But make sure your curve is nice and smooth, no kinks in it, and not feathered, just one straight smooth curve. And note that the curve is n-shaped, and that's the difference having the negative x squared makes to your curve. When your equation is y equals and it's negative x squared, your curve will be n-shaped. So you can think of that as n for negative and n for the shape of the curve. Label it at the end, and that's the job done. Now, this is what a curve should not look like, okay? It shouldn't look like this. Let's see what's wrong with it. First of all, it shouldn't have a flat bottom, okay? It should have a nice turn on the bottom. So essentially, from these 2 points here, we've gone down too far and then flattened off and then gone up again. Shouldn't have a flat bottom. The curve should be smooth. We can see there's a little kink here in the curve. Okay, shouldn't be there. And this point here doesn't look right because again the curve has got quite a big kink in it here. It sort of kinks inwards. It doesn't look right. So we need to check our table of values, and in actual fact that is the wrong value. It's not 24. So sometimes you have a table of values which is wrong, but you don't notice it until you've plotted the curve. So your curve needs to look right. As it happens, that value should have been 20. So let's put all this together with a recap. Those 3 diagrams that you see, those are the equations of 3 quadratics. What do they all have in common? Well, they are all symmetrical about the point where the curves turn. albeit they're not fully complete. If they were fully complete, they would be symmetrical, and they should be symmetrical. Each of those curves is drawn with a nice smooth line. The turn on the curve is not flat, it's a proper turn, it shouldn't be flattened. The two curves on the left-hand side are U-shaped because they are both positive x squareds in their equation. And the one on the right-hand side is a negative x squared in the equation, hence it's n-shaped. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.